Hello, welcome to this lesson of our study of vectors and mechanics. Okay, so in this lesson we'll go through the addition of vectors. If you have not subscribed to my channel, kindly subscribe for more videos. Okay, alright, so in vector addition we have three ways of doing that. Okay, we have first of all the triangle law of vector addition. Okay, and we also have parallelogram law of vector addition, like that. Okay, and we have the resolution law. But here we will stick to both the triangle law and parallelogram law, and the resolution law we will talk of it much in our lesson of electrostatics. Okay, so if you want to know how the resolution law works, just watch my videos on how to find the forces or electric field intensity existing between charges due to different charges at different angles. Okay, so that one you'll be able to understand the resolution law, but here in mathematics you deal with the triangle law and parallelogram law much. Okay, so let's start with the triangle law. So if you have two vectors, you should take note of the directions. Okay, so two vectors like this, you have AB and BC, or you have small a and small b here. You can see that a started from somewhere, this small a here, I'm talking about the small a, it started from somewhere and ended, and the b started from exactly where it ended. So this is how you position vectors so that you can add them. So once you start from the ending point or the terminal points of one of the vectors. Okay, I hope you understand. So one start from somewhere, then the other start from the terminal point of the one that started. Okay, alright, so in doing this, we have two vectors that have been placed on the two adjacent sides of a triangle. Okay, or the two sides of a triangle in order like this. So the direction moves like that. Okay, we are all moving in the right direction. So this goes here, sorry, um it goes here, then this also follow like that. Okay, so they are supposed to move in order. Okay, so with this, then to find the resultant force, the resultant vector will be the third side of the triangle, I mean this side. Okay, if they are moving in that order, then the resultant or the final vector for this whole system will be the third side of the triangle. Okay, and that will be given by AC. Vector AC will be equal to vector AB plus vector BC. Okay, I hope you understand this. If in case it was something like this, this, and let's say BC was in this direction. Okay, then in order to find our AC, let's say here is A, here is C, B, like that, then our AC will be equal to AB minus CB. Okay, because if you remember in our first lesson we talked about opposite vectors. We said that the vector AB is the same as the negative of BA. Okay, so vector BC here is the same as minus CB. So if the directions were different, like this one I've done here, then it means that will be the way we'll do it. Okay, or that will be the way we'll have to do it. Okay, I hope you understand it. So let me write the formula for you. That if you have this, then your final answer will be AC will always be equal to AB, okay, plus BC, or small c, okay, we use C here, is equal to small a, okay, plus small b. I hope this is okay. So this is how you use the triangle law of vector addition. Okay, alright, let's go to the next one, the parallelogram law of vector addition. It also states that if you have two vectors that have been represented in the two adjacent side of a parallelogram, so you could see that here we have vector OB here, they are all starting from O, and you have OA here. Okay, now with this, if I want to find their resultant or their final vector, okay, from this, then it will be the adjacent line the diagonal, okay, a diagonal drawn from their common point. Okay, that is how the law states. Okay, so if I want to find this diagonal, then you can see that if I draw a parallel line to, or yeah, if I draw a parallel line to B, which will be the blue pen, okay, this side, which will be this side, that will be the same as B, okay. Here is the same as small b, and to the top side is also the same as small a. Okay, so if I use the triangle, this triangle here, since we know the triangle law, if I use this triangle, let me use a proper pen so that you could see what I'm trying to do. Okay, let me use the red pen for this, and I use blue for this one. Okay, and here was white. Okay, I'm taking some triangle out. I'm taking this side of the triangle. Okay, now with this you can see that here is O, this is A, this is C, and you can see that with this, using the triangle law, we can say that OC, which is the diagonal, we are saying that that diagonal is the resultant or the final answer for what we want. Okay, so that diagonal is equal to OA plus AC. Okay, I hope you understand that. So in simple term, it will be OC, which is, let's say, small c, should be equal to small a plus small b. So in effect, we've come back to the triangle law of vector addition. Okay, so you can also use the triangle law inside the parallelogram law. Okay, I hope you get what I'm trying to do here. Alright, so with this, if I consider the other triangle as well, okay, this one, let me draw it with the pen so that you get to know it as well. Okay, if I use this side of the triangle, let me use, okay, here is B, okay, and it's going this way. Here is O, here is C, and here is A. Okay, then you could see that since they are moving in the same direction, you see this is going here and then going here. Okay, you have to check the direction very, very well, because that is what will tell you how your addition will be. So with this, OC is equal to this B here, okay, this one, B here, plus this A, and OC we are calling it small c, so it's the same as A plus B, or let's say this. Anyhow you do it, it works. Okay, and this idea is from some properties of addition of vectors. Okay, so you can see that any way you want to go, your solution is the same. If you go the other side, you get the same thing. Okay, so it means always the solution to your vector or your vector addition in terms of parallelogram, using parallelogram law, is as a result of using the triangle law. Okay, so in effect it's like you are using the triangle law to solve this. Alright, so like I said, C is simply equal to small a plus small b. Okay, so in our next discussion we talk about example, we take examples and go through them, but let's look at this property. We have properties of vector addition, and the first one is commutative, meaning vector addition is commutative. It means that if you have vector a plus vector b, is the same as vector b plus vector a, and associativity as well. Okay, so vector a plus vector b or plus vector c is the same as vector a, let me write it to vector a plus vector b plus c. Okay, so any way you want to go, this is true. Okay, so in our next discussion, like I said, we'll take an example and work through it so that you understand the concept very much. Thank you, and don't forget to subscribe to my channel. Okay.